So in order to recap what I just did, we just adjusted this arm right over here. Hey, what's up everyone? Your buddy Matt here. So a little while back I was filming a forklift video for my new series and I wanted to perform a compression test. I looked all over for my compression tester, but I could not find it. Then I remembered I lent it to my brother-in-law about 6 months back. Which compression tester are we talking about? This one right here. I went and got it and noticed something a little peculiar about it. The gauge did not go back to 0 like it once did. Now normally I'd just throw this thing out and buy a new one, but I was given this gauge by my grandfather when I was about 14 years old, just starting to get into mechanics, so I do cherish it quite a bit. The problem is, I don't know if I can trust the readings on this compression gauge anymore. And like they say, if you can't trust your compression gauge, what can you trust? So the question to be asked is, can you calibrate these things when they're not giving you an accurate reading? Can you fix them? I mean, sure, you could just change this part with a new one, because when you look at what this thing is, it's basically just a bunch of fittings and a standard pneumatic gauge on the top. But I'd like to see if I can get this one working again. Now, in order to do that, I ended up buying a bunch of fittings to put together a sort of test unit, something that I can validate that I know is running properly and compare to this one. If I make any modifications, I can see if it's acting the way we want it to. So let's check and see how we're going to build this test gauge. So this is the basic setup I'm going to be using. Air is going to come in from my compressor and branch off into two separate lines. On the first line, I'm going to have my faulty compression gauge. On the second line, I'm going to have this, we'll call it calibrated gauge, that's going to give me what I actually have in terms of line pressure. If I make any corrections to this guy, I'll be able to check and see whether or not they're accurate. Let's quickly put this together. So I would like you folks to meet my compressor. We're going to be using them for this test. Now, none of my gauges are actual calibrated gauges, by an outside certified organization. However, I do have 1, 2, 3 gauges that hopefully will all indicate about the same thing, and I'll be using that as good enough for calibrating this defective one. So one thing that's important to note is that this gauge here's graduations are 2. Every little line is 2. The medium-sized lines are 10, and then we have the PSI number actually indicated. This guy over here, the small lines are 5, and the indicated lines are going up by 25. This gauge maxes out at 160, this one 300. In order to get a fully functional compression tester, if this entire thing doesn't work and I have to actually replace this gauge, I'm going to have to get one that goes up a little higher than 160. But for right now, for the test, we'll be okay with that. Now, if we look at the error that's on this guy right now, we're at about 37, 38 PSI, which would be the quote-unquote 0. I have my compressor set at 60 PSI, and let's energize the system to see what happens. So by energizing the system, I guess I ended up bleeding out a little bit of air. So I'm going to bring the compressor back up to 60 with the pressure regulator. Okay, we're pretty much spot on at 60 over here. And what do we have? We have 95 on our defective gauge. So 95 minus about 37 to 40 PSI is roughly 55 PSI. Let's increase the pressure to 90 and see what it does. So we are getting 90 over here, and we're getting about 125 on the defective gauge. And that's about 85 to 88 PSI. So we are pretty close. Maybe this thing just doesn't go back down to 0. Let's open it up and see what makes it tick. So by removing the 2 screws on the back, the bezel, and sliding it out of that casing, I was able to expose this mechanism. Now, the way a pressure gauge works is air pressure comes in, goes through this copper tube that's bent in a way that as the pressure increases, it ends up moving the tube slightly, and there's a very precise little system of gears in here that ends up moving your gauge needle. Now, because on this particular gauge I'm offset by about 40, I wondered if I could just jump this little gear over here that engages the needle. And by looking at the mechanism, everything's riveted and I can't really get to it. I don't want to bend this tube because I assume that that's designed in a way that gives you your actual accuracy, and maybe the radius is important. None of the levers are adjustable and there's nowhere that I can see to adjust it. However, I noticed that as I press on it, I press down and I see that the gauge comes down. When I pull, it comes up. Basically, this mechanism has to move down slightly. And right over here, soldered onto this pressure tube, is a little mechanical arm that if I come in with a screwdriver and bend it ever so slightly, you can see we're going in the right direction. Now I'm going to give it a little bit of a bend, and we can see that we've reduced our needle down closer to our 0 mark. We're going to continue doing that just a little bit at a time until we end up getting our 0. Look at that, we're almost there. Is that close enough? It hits. It doesn't, not quite there. Let's give it a little bit more. Okay, that's touching. All right, let's put the gauge back together and see if that fixed it. So we're set back up once again in our little test system. Both gauges are indicating 0, and we'll put 60 psi on them. All right, so we can obviously see that we have 60 psi on our calibrated gauge. And this guy over here, we're at 55, 60, 65, about 68 psi. So not quite there. We're actually overshooting a little bit. Let's take it back apart and see if we can adjust it a little bit more. So I've taken the gauge back apart, and what I did was I ended up giving it a little bit more pressure over here. So I wasn't too sure how much pressure we had to have on that pin. I ended up bringing it down so it just barely touched it. Now I gave it a little bit more. Let's put the pressure back on the system and see if our changes made any difference. All right, so now we have 60 on our calibrated gauge, and we're at about 55 on this guy. That means that our little tab went a little too far. What we're going to have to do is take a set of pliers and just bend it back to where it was a little bit. These are like the slightest movements we're trying to make here, not a little too much. It's kind of like a trial and error. How does that look? 60 and 60. All right, let's try taking it up a little higher and seeing if it still reacts the way we want it to. All right, so we brought our pressure up to 90. Are we at 90 on this guy? Oh, a little bit over 90. And I'd say this guy too, we're at a little over 90. Let's bring it down to 30 and see what it does. And we're pretty close to 30. So let's take the gauge off and see if it goes back down to 0. Sure does. So in order to recap what I just did, we just adjusted this arm right over here by bending it, by putting my screwdriver and bending it outwards a little. I would bring my gauge down, and if I took a set of pliers and bent it back, I'd end up bringing my gauge up. Once I was happy with where my zero setting was, I ended up putting pressure in, bringing it up to a fixed value, and then making those micro adjustments while under pressure in order to get it right about there. At which point I then tested at different pressure settings, and within the range that I tested, 30 to 90, I ended up getting a pretty adequate result. All right, folks, we did it. We calibrated our old sentimental compression gauge. Now, I just want to make sure you all understand that I'm in no means an instrumentation specialist. I have no idea if what I just did is the proper way of calibrating a compression gauge, but for my intents and purposes, it did the trick. Hope you guys enjoyed the video. Stay tuned for the next one. Signing out.